Hello friends, you can log on to primeaptacademy.com to access complete free video courses. Okay, so this is the 11th question of the number theory chapter. So the question says, how many, this is not any, this is many, how many 3-digit positive numbers are divisible by 2, 5 and 7? So how many 3-digit positive numbers are divisible by all these three? This might seem a very trivial question at first, but this is not that simple. This is a question based on set theory. So you have to understand that first of all 3-digit numbers, that means number starts from 100 and goes on till 999. So between these numbers, how many of them are divisible by 2? So if I just find the numbers which are divisible by 2, 100, 100, 102, 104, so on till 998. So how many of them are here? This is 2 into 50, which is 100. This is 2 into 499. Okay, 499. So 2 into 499, 2 into 50. So how many numbers are there in between? It is 499 minus 50 plus 1. Why plus 1? Because all these have to be included. The limits have to be included. That is 449 plus 1, which is 450. Okay. So 450 numbers are divisible by 2. That we know. So now over here, 450 are divisible by 2. Similarly, now we'll find how many of them will be divisible by 5. So if I start with 5, this is 100, 105, 110, 115, so on till 995. 100 is 5 into 20, okay, and 995 is 5 into, this is 5 ones are 5, 4 9, 5 nines are 45, again 4 5, 5 nines are 45, that is 199. Okay, 200 into 5 is 1000 minus that. So over here, number of how many of them are divisible by 5? If I find that, that will be 199 minus 20 plus 1. Why plus 1? Because I am taking both the end numbers. So 199 minus 20 is 179. 179 plus 1 is 180. Okay. Now the first thing that you encounter here, there will be some common numbers in both the list, which I am counting twice now, because 450 of them are divisible by 2, 180 of them are divisible by 5. But if you look at numbers like 100, 100 is present in both the list. If you look at 110, 110 will be here, also 110 will be somewhere here. So all the numbers which are multiples of both 2 and 5 will be present in both the lists. So I have to deduct those numbers, number of those numbers. Because why? Because I am double counting. So first of all, now if I find the number of numbers which are divisible by both 2 and 5, we will look at 7 later on further. So if it is 2 and 5 again, so if it is 2 and 5, number of numbers which are divisible by both 2 and 5. Okay, that will be 450 plus 180, 180 minus number of numbers which are multiple of 10. Because I have double counted multiple of 10. Multiple of 10s which are 100, 110 are counted here. Also multiples of 10, 100, 110 are counted here. So if I am counting it here and here, I have to just count it once and not twice. So I have to subtract it once. So how many numbers which are multiple of 10 that will be there? So multiple of 10 will be now 100, then 110, then 120, so on till 990. So this is basically 10 into 10 and this is 10 into 99 or 99 into 10. Okay, so how many of them are multiples of 10? In this case, number will be 99 minus 10 plus 1, which is 89 plus 1, 90. So 90 of them are multiple of 10. So 450 plus 180 minus 90. These many numbers are divisible by both 2 and 5. So that will be how much? If I do that, this will be 450 plus 180 minus 90 is plus 90. So 450 plus 90 is 540. So 540 of the numbers are divisible by both 2 and 5. We still have to tackle 7. We'll go with the 7 case further. So now if you look at it, first of all I'll find out how many of these numbers are just divisible by 7 alone. So now first we have to find that closer to 100 which is a multiple of 7. So I know 98 is actually a multiple of 7. Okay, that is 7 into 14. If I do 7 into 14, that is 98. That means the next multiple of 7 is 105. Okay, so next multiple of 7 is 105, then it will be 112, then 119 and so on. The last 3-digit number that will be a multiple of 7 if I have to find, that will be 1000 divided by 7. So 7 ones are 7, then 3 zeros, 7 fours are 28, 2 0, 7 twos are 14, 6. So I get 6 as the remainder if I divide it by 1000. So 6 minus that is 994. Okay, so 1000 minus the remainder is, because what is 1000? 1000 is 7 into 142 plus 6. So if I do 1000 minus 6, that will be 7 into 142. Okay, that will come out to be 994. So 994 is the last number, and this is 7 into 142. I have also figured this out. This is 7 into 142. This is 7 into 15. This is 15 into 7, and that is 7 into 142. So now over here, how many of them are just multiple of 7? That will be 142 minus 15 plus 1. Plus 1 again because I am taking the end numbers. Okay, that will become 142 minus 14. So that will be 142 minus 14 is 142 minus 4 is 138, 128. Okay, so this is 128. So 128 numbers are there which are just multiple of 7. Now similar to the previous case wherein there were multiples of 2 and 5 both, in this case there will be multiples of 2 and 7 both. Also there will be multiples of 5 and 7 both. Okay, also there will be multiples of 2, 5 and 7, all of them, and we have to see what we do with this. So now here if you look at it, I already have these 540 numbers. 128 are multiples of 7. So now if I do 540 plus 128, this from here if I deduct multiples of 2 and 7, I have to do that. Why? Because multiples of 2 are already counted here in this 540. Okay, in this 540 I already have multiples of 2 and 5. So they are already counted here. In this 128 there are multiple of 7s which are also multiples of 2s. So I have to deduct those multiples of 2 and 7. Similarly, I have to deduct multiples of 7 and 5. Okay. Now if you look at it here further, that here I am deducting multiples of 2 and 7, here I am deducting multiples of 7 and 5. But what happens with multiples of 2 and 7 and 5? 2 and 7 and 5. That those multiples are present here because these are multiples of 2 and 7. So it might have some of them which are multiples of 5 also. Here again also multiples of 7 and 5 is, it might also have some numbers which are also multiples of 2. So multiples of 2, 7 and 5 are deducted twice. So that means I have to add it again to give me the right answer. Alright. So that is why I told you in the beginning, this is a very complicated question. This is not just a straightforward question. Looks like a very trivial one, but it is basically you have to have thorough knowledge of sets and how sets work. These are nothing but sets over here. So here it is 2 and 5. This is 7 only. This is 7 only. Now if I have to find multiples of 2 and 7. So 2 and 7, that means even numbers over here. So you start with 1, 1, 2. Okay. So 2 and 7 is basically multiples of 14 that you are looking at. Multiples of 14. Okay. 7 and 5 is very simple. You take multiples of 35 that you are looking at. 2 and 7 and 5 you take multiples, because if you take the LCM that will be 2 into 5, 10 into 7, 70. So you are taking multiples of 70 here. And just we have to find that in this list which are 3-digit numbers which are multiples of 14. And we'll plug that number, 3-digit numbers which are multiple of 35, we'll plug it, and 3-digit numbers which are multiple of 70, we'll plug it. So 2 and 7 if I find further, so first of the number that I get is 112, okay, 112. Then again the next multiple of 14 is 126, and so on. Till 1000 if I have to go, 994 I know is a multiple of 7 and it is also a multiple of 2 because it's an even number. So 994 I'll write it directly. 994. So how many of them? This is this will be 112 is 14 into 8, I believe. So 14 into 8, 8 4s are 32, 3 here, 8 1s are 8, 311. Yeah. This is 14 into 8. This is 14 into 8. And this is what? 14 into. So if it is 7 into 142, if I take this two, one of the 2's here, that will be 14 into, this is 7's and 1's, 71. 14 into 71. If you want to check, you can do that. 71 into 14. 4 1's are 4, 7 4's are 28, then 1 and 7. That is 4, 9, 9, 994. Yeah. So 14 into 71. So how many of these numbers are multiple of 14's? That will be 71 minus 8 plus 1. So 71 minus 8, 70 minus 7 is 63, 63 plus 1 is 64. This is 64 here. Okay. That is, or you can treat it as 72 minus 8. That is 64 here. So 2 and 7 is 64. This is what we know now. Now 7 and 5, which are multiple of 35. So 7 and 5 first I get is 105. Straight away I see 105 here. So 105 I start with. Then 35 further, which is 140 is the next one. So on. Now I have to find near 1000. Near 1000, if I divide by 35. 35 2's are 70. And here is 30, 300. 35 into 350 and further 50 less than that. 35 into 8 it will be. So 35 into 8 if I do, 35 double is 70. If I am multiplying by 8, I can double and double and double. So 35 into 2 is 70, 70 into 2 is 140, 140 into 2 is 280. So 35 into 8 is 280. So 20 is the remainder. That means 20 less than this. So 20 less than this is 980. So this is 980. Also if you look at it, if I deduct 7 and 7 further from here, I get 980. So this is 980, and which is 35 into 28. So this is over here is 35 into 3. 35 into 3 is 105, and this is 35 into 28. So how many of these numbers are there? 28 minus 3 plus 1. 28 minus 3 is 25. 25 plus 1 is 26. 25 plus 1 is 26. Or you can write it as 29 minus 3. Now finally, we have to now take care of 2 and 7 and 5, which are multiples of 70. So 2 and 7 and 5 means the first multiple of 70, which is a 3-digit number, is 140. Then it is 210. Okay. Then it is 280. So on. So if you do 1000 upon 70, if you have to find, that is that will come out to be 980 further. We know that because this is 35 into some even number. So this is 35 into 2 if I do, that will be 14. 70 into 14 it will be. Okay. So that is 980 for sure. Okay. This is 980. This is 70 into 2. And this is what? 70 into 14. That was 35 into 28. Yeah. That is 70 into 14. Alright. So how many of these are there then? 14 minus 2 plus 1. 14 minus 2 is 12. 12 plus 1 is 11. So now I have all these numbers to plug that and get the answer. So answer will be 540 plus 128. Answer is 540 plus 128 minus 2 and 7, that is 64, minus 64, minus 7 and 5, which is 26, plus these 11, which is all the 3. Okay. So writing this is very important in this manner. So over here what we get as the answer is 540 plus 128. 540 and 100 is 640. 640 and 20 is 660. So this is 668 So if I do 668 minus 64 first of all, so 668 minus 64 is 604 straight away, that is 604. 604 minus 26 plus 11, so you could have written this as minus 15, okay, that is 26 minus 11 is 15, so it is minus 15. So 604 minus 15 I get. So 604 minus 5 is 599 and 10 further, that is 589. So 589 is the final answer that I get. Okay, so 589 is the final answer to this question. So how many 3-digit positive numbers are divisible by 2, 5 and 7? 589, and that is the right answer. All right.